Hello and welcome to Diksha Karnataka YouTube channel, and in COMEDK series today I am going to discuss a very important chapter, which is current electricity. So that's why I have decided not to discuss two chapters in this part, because current electricity is one of the most important chapter of COMEDK. 5 questions you can expect from this chapter alone, right? So this is one of the most important chapter of COMEDK. So let us start with the previous year questions. Very important 15 previous year questions from this chapter. So let's start. And those who are wondering, this chapter is also important for your KCET as well as any competitive exam which you might be interested in. This is one of the most important chapters. So if you want to revise for KCET or any other exam, yes, you are welcome to watch this lecture till the end as well. So let's start. Wire A and wire B has the following ratios: length LA divided by length LB equals to 5/8, diameter DA by DB is 2/3, resistivity rho A by rho B equals to 4/9. What is the ratio of resistance of wire A to the resistance of wire B? Now we know that resistance of a wire is given by rho L by A. Now here A represents area, so area means what? We can write this as rho L by pi d square upon 4, right? Area is what? Area is pi r square. Now what is r? R is diameter divided by 2. So here if you see that diameter's ratio is given, anyway it does not matter, diameter's ratio, radius's ratio are all same, because question it is given D, so we cannot ignore that, so we will use it, right? So you can write this as 4 by pi rho L upon d square. Okay, 4 by pi rho L by d square is the resistance of a wire. So if you take the resistance of RA divided by RB, what you will get? You will get rho A LA divided by diameter A and whole divided by rho B LB whole divided by diameter B, right? So basically you can say that this is the formula for ratio of the resistance. Now if you simplify this, you will get rho A by rho B into LA by LB into, because both of them are division of division, so it will be inverted, it will be DB by DA. Now let's put the values. Rho A by rho B is given here, 4/9. LA by LB is also given, 5/18. Now DB by DA will be opposite of that, so it will be 3/2. Okay, so it will be 3/2. So now let's simplify. You can simplify any which way you want. 3 6 are 18, 2 2s are 4, so you get 10 divided by 54. So it will be 10 divided by 54. So the ratio will be 10:54. Okay. Now next question. Figure A and figure B both are showing the variation of resistivity rho with temperature T for some material. Okay, you have to identify which material are they. So here if you see that resistivity for material A, this is figure A, figure A. So if you see the resistivity of in figure A, it is increasing. So resistivity increasing with temperature. So which materials resistivity increases with temperature? That are basically conductors. For conductors, resistivity increases with temperature, and here you see that resistivity is decreasing with temperature. So resistivity decreasing with temperature means what is that? That means it must be a semiconductor. For semiconductor, so not all questions are difficult. Okay, if you have studied some of the concepts deeply, you will be able to answer that. So it is conductors and semiconductors, it is the correct order. Okay. Now next question. Two two batteries of EMF 4 volt and 8 volt with internal resistances 1 ohm and 2 ohm are connected in a circuit with resistance of 9 ohm as shown in the figure. The current and potential difference between the points P and Q are respectively. So basically in this problem, if you see, here we have point P and point Q. So whatever the potential difference between these two points, the same potential drop will be between R and S. So if you can somehow find the current in the circuit, whatever it is, okay, and if you multiply this current with this 9 ohm, you will get the voltage drop across the combination of the cells. Now if you see that here in the combination of cell, this one is negative, this one is positive. For this 8 volt, this one is positive, this one is negative. That means they are not connected in series, but they are connected in reverse order in series. So that means what will be the equivalent EMF here? The equivalent EMF here will be 8 minus 4, that is 4 volt. Okay? You cannot simply add them unless and until they are connected in order. If they are connected in order, then it becomes E1, E2, then it becomes E1 plus E2. But if they are connected in reverse order, then you have to subtract one from another, right? So you cannot simply add them here. You have to take the bigger minus smaller, always bigger minus smaller. Okay, and the bigger one will dominate, so the current will flow in this direction. Okay, now what is the equivalent resistance of the combination? Equivalent resistance of the combination, in this case resistances do not follow polarity, so it will be simply they are connected in series, so 1 plus 2, that is equals to 3. So what is the total resistance? Total resistance will be the external resistance plus the equivalent resistance, that is 9 plus 3, that is 12 ohm. So what is the current in the circuit? Current in the circuit will be equivalent EMF divided by the total resistance, that is 4 divided by 12, that is 1/3 ampere. Now you don't need to solve it after that, because if you see the options, only one of the option is given here, 1/3 ampere. So option A is correct, but in some cases you might need to calculate the voltage. If they give the same current, suppose the same current is given in 2-3 options, then how to calculate the voltage? Very simple. As I mentioned, voltage is nothing but take this resistance, multiply with the current, that is the voltage drop across this, and same voltage drop will be converted here as well. So it is 9 into 1/3, that is 3 volt. So if you see that, this is also matching. This is a confirmation that okay, our option A is correct, right? Now let's move on to the next question. The resistance in 4 arms of a Wheatstone network in a cyclic order are 5, 2, 6 and 15. If a current of 2.8 ampere enters the junction of 5 ohm and 15 ohm, then the current through 2 ohm resistance is. So here we have a Wheatstone bridge, okay, and obviously we have a galvanometer. Now nothing about the galvanometer is given, so that is a hint of this question, and they have given you the order 5, 2, 6 and 15. Okay, 5, 2, 6 and 15. So this is P, this is Q, this is R, this is S, right? We know the condition for balance is P by Q equals to R by S, right? So let's check whether this condition is satisfied or not. So P by Q means 5 by 2 and R by S means 15 by 6. Is it okay? So let's see. 3 5s are 15, 3 5s are 15 and 3 2s are 6. So yes, on left hand side, right hand side, both sides are equal to 5 by 2, so the balance condition is satisfied. So if balance condition is satisfied, then we can say that there is no galvanometer. This portion we can simply delete, right? So it is basically parallel combination of resistances. Now here 2.8 ampere is entering this junction. Okay, it's mentioned that 2.8 ampere enters 5 ohm and 15 ohm. So this is the entry point. Now it says that what is the current through this 2 ohm junction. So if current passes through this say I1, current divides here say I2, then this must be also equals to I1, right? And this must be also equals to I2, right? Now what? How to approach such questions? It might be feel difficult for you to understand beyond the point is that I1 plus I2 equals to 2.8. This is certain from Kirchhoff's current law. Okay, 2.8 ampere is entering this junction. That means I1 plus I2 equals to 2.8. Now what? Now we realize that this 5 ohm and 2 ohm are connected in series. Okay, and the current through them is common, that is I1. So what is the total resistance of this point? The total resistance of this point will be 5 plus 2, that is 7. And what about the below one? Below one we have 15 and 6 again in series. So the below one will have a total resistance of 21. Okay, so this is 7 ohm, this is 21 ohm. Current through this is I1, current through this is I2. Now obviously we can say that the voltage drop, because they are connected in parallel, the voltage drop across this, okay, this resistance should be equals to voltage drop across this. They are connected in parallel means the voltage drop must be same. So what is the voltage drop across any resistance? Voltage drop across any resistance is current times the resistance value. So 7 I1 must be equals to 21 I2, right? Voltage drop across this is 21 into I2. So from here we can say I2 equals to 7 by 21 I1 or 1/3 I1. Now we will use that back here and we will simplify. I1 plus 1/3 I1 equals to 2.8. Why we are substituting like this? Because our ultimate goal is to find I1, that is resistance, current through 2 ohm resistance. So 4 by 3 I1. If they ask you what is the current through 6 ohm, then we have substituted I1 equals to 3 I2, because that then our goal would be finding I2. So based on what current you are calculating, you need to adjust your calculations so that you calculate that faster. Now in COMEDK, as I mentioned in the past as well, you are allowed to use simple calculators, but most cases you don't need it. For example, here you don't need it. So 2.1 ampere is the correct answer. So 2.1 ampere is the correct answer. Now let's move on to the next question. In the circuit shown in the figure, select the correct option. Current passing through 2 ohm resistance is 0. Current passing through 4 ohm resistance is 5 ampere. Current passing through 5 ohm resistance is 4 ampere. All of these. So basically, because we have an option like all of these, we have to check all the options. First of all, if you see that here we have a 0 resistance wire, so no current will be passing through this 2 ohm. 2 ohm is actually, we can say that 2 ohm is connected parallel to 0 resistance. If anything is connected to 0 resistance, parallel to 0 resistance, that is actually equivalent to 0 resistance, and current always like to flow through the least resistive path. Okay, so basically when the current comes over here, it says that I cannot go and loop like this. I have to come back to my battery, that is my source. So from here it will go in this direction and it will go in this direction. It will not go any way near to the 2 ohm resistance. That means current through 2 ohm resistance is correct. So this statement is correct. No current is passing through 2 ohm. But we have to find the current through 4 ohm and 5 ohm and check that whether the other two statements are correct or not, because all of this is the option. So how to find the current through this 4 ohm? So the voltage that we have applied is 20 volt. So here it is obviously connected in parallel to this. So this entire 20 volt is falling on 4 ohm. So current through 4 ohm is actually the voltage that you have supplied divided by resistance. I equals to V by R. So that is 5 ampere. So current passing through 4 ohm is 5 ampere. Correct. So we are getting the Y. What will be the answer? Obviously. Now let's take the last option, current passing through 5 ohm, 20 by 5. Again it is in parallel combination, so same voltage is applied to this as well. So it will be 4 ampere. So obviously this is also correct. So all of this is correct. Okay, so in such case, if you are in a hurry, okay, if all of this is an option, you at least have to check 2 options. If 2 options are correct, third option will automatically be correct, then only all of this is possible. 2 option, generally we do not have multi-correct option in COMEDK. Okay, so that means only 1 option will be correct. So that means this has to be the correct answer. Now, next question. Before going into next question, just wanted to remind you, those who want to register for COMEDK crash course, we currently have our 30-day COMEDK crash course, which is currently available for a price of 2499. If you really want to score well in COMEDK exam, and which is really possible, then you have to do it today. Classes will start from 6th of April. Classes will start from 6th of April. So if you have not registered for this, do register today. Okay, and remember that COMEDK exam, even if your board exams are not that good, you can still score well in COMEDK and take admission in many of the top colleges of Bangalore, okay, like RVC and BNS, etc., Dayanand Sagar. So there are many colleges where you can take admission if you can score well in COMEDK exam alone. Only you need to score, I think, 45% or 50% marks in your board exam. So board exam weightage are not there like KCET. So you just need to do well in the exam itself. That will give you a good rank, right? Now let's move on to the question number 6. One more thing, the link of the joining the crash course is given in the description section of this video. The Kirchhoff's first law, delta I equals to 0, and second law, delta I R equals to E, where symbols have their usual meanings, are respectively based on. So Kirchhoff's first law is based on conservation of charge. Okay, current equals to 0 means the total charge that is coming out of the battery must go back to the battery or cell. Okay, so charge has to be conserved. Charges cannot be created or destroyed in an isolated system. So basically this is the conservation of charge principle. Whereas IR equals to epsilon, the sum of E, actually represents the conservation of energy. Whatever voltage is being dropped by the battery, that same voltage is equally distributed among the resistances. So that means it's a conservation of energy principle. So conservation of charge and conservation of energy. So option A itself is the correct answer. Now let's move on to the next question. The IV graph for 2 different electrical appliances P and Q are shown in the diagram. If RP and RQ be the resistances of the devices, then which of the relationship is correct? So you have to understand one thing here. Voltage is plotted along x-axis and current is plotted along y-axis. That's it. If you understand that, your 50% problem is solved. So we know that if we can write an equation like y is equal to mx plus c, then we can say that, okay, the m represents the slope of the graph, and if we can find the slope, it helps us to identify which value is, which angle is more, which angle is less. So let's see, can we find the equation for these 2 points or not? So we know that V equals to IR. So what is V here? V is along x-axis. So x equals to, what is I here? I is along y-axis. So y into r. But our equation has to be in this order. So y equals to 1 by r into x. So if you find the slope of this graph, then that slope will give you reverse of the resistance. So higher the slope, smaller is the resistance. Smaller the slope, higher is the resistance. Okay, this is one way to solve. There is one more way to solve such question. Here you can use directly this relation, V is equal to IR, or R equals to V upon I. So if you take a constant I, For example, this is the I is constant, right? And if you see that whoever is giving you higher voltage will have a higher resistance as well, right? For constant I, resistance is proportional to voltage. So here if you see that who is giving you higher voltage, which is bigger, obviously further from the origin means a bigger value. So this one will have Rp is bigger than Rq. You can calculate the slope from here also, calculating the angles, okay, and you can say that, okay, angle is more for Q, that means it will have a less resistance. Angle is less for P, that means it will have a higher resistance. Or there is one more, this is a shortcut trick where you take the current to be constant, okay, because we know that V is equal to IR, R is equal to V by I. So if you keep current constant, okay, that is you draw a parallel line along the x-axis, that is a constant current graph, okay, at this constant current who is giving you higher voltage. So this one is giving you higher voltage, means this must be having higher resistance as well. So correct relationship is Rp is greater than Rq. So Rp is greater than Rq, so correct answer option B. And you cannot say if this relationship is correct or not unless these angle values are given. If angle values are given, you can calculate the resistance value exactly from the slope, but because it is not given, you cannot say Rp is equals to Rq by 2 or not. But this one is obviously we can say Rp is greater than Rq. Now let's see this question. In the part of the circuit shown in the figure, the potential difference between point G and point H. So we have to find the potential difference between these 2 points. How to solve such question? This is a part circuit. Obviously a complete circuit is not shown. We have given some current 2 ampere coming over here and no current shown in this 1 ohm. That means is the current 0? Obviously not, some current is passing through that. You have to find that current out. Also here if you see, here we have 1 ampere out, 3 ampere out. Okay, these resistances values are not shown because they are not required. How to approach such question? We have to start from where it is not given, okay. So here if you see that 1 ampere is going out here and 3 ampere is going out here, Kirchhoff's current law says that means the current which is coming in must be 3 plus 1, that is 4 ampere. So 4 ampere current must be going in here. Okay, now it is a battery. So battery means whatever current is going out, the same current has to come back here as well. So 4 ampere current must be passing in this direction as well. So 4 ampere current is passing in this direction. Obviously it is in reverse condition, okay. That's why 4 ampere current is passing like this. So it will go like this, go somewhere here and then come back through this. Okay, so 4 ampere current has to go back, conservation of charge. Now if you see that this 2 ampere current is passing here, this 2 ampere current, there is no other path, so it has to go through this and 2 ampere current will arrive over here. Now after this junction, the current becomes 4 ampere. Up to this junction, 2 ampere is from this side. So what will be the current from this side? Current from this side will also be 2 ampere, so that 2 plus 2 becomes 4. Okay, so this is as easy as 2 plus 2 equals to 4 problem, right? So 2 ampere from this 1 ohm going upward, 2 ampere from this side coming here, and they are merging here, and that's why the total current becomes 4 ampere, and that 4 ampere comes over here. It is again dividing into 1 and 3. So you have to start from the back and then go in the forward direction. So now we know what are all the currents that is being passing through G and H. Okay, we will ignore whatever is not there in this portion. We will completely ignore that portion. Okay, so now what? Now we will apply Kirchhoff's voltage law. So what is the Kirchhoff's voltage law? Kirchhoff's voltage law says that suppose we are starting with Hg and H, right? So Vg minus Vh. Okay, also we have one more cell over here, which is also, if you see that, sending the current in the direction. So you have to add this voltage with this potential difference, that is 3. If it was sending current in the opposite direction like this one, then you have to subtract it, okay? So this is the voltage part. Voltage part is sorted, and that should be equals to voltage drop on across individual resistances. 4 into 2. First part is obviously voltage difference between these 2 points. These 2 points we are trying to find. Is there a battery? Yes, there is a battery. Is the battery sending current in the direction where it should be? For example, is it current is exiting through positive or entering through positive? So if the current is entering through positive, then it will be negative. This will be negative. If the current is exiting through positive, then it will be positive. Okay, this is how we solve it. There are other ways also. Sometimes you take the voltage on the other side. That is also fine. If you are confident with this method, whatever method you have, you can use that. Okay, so Vg minus Vh plus 3, this is the total voltage between these points, and then we will apply Kirchhoff's voltage laws for individual junctions. So current is going in this direction. We are also starting from G, so 4 into 2. Next we are going in this direction, so 2 into 2 plus 2 into 2. Next we are going in the opposite direction. So it must be minus 1 into 2, because G to H we have to reach. Okay, Vg minus Vh we are finding, not Vh minus Vg. That's why whatever direction we will take, that direction is important. Okay, and we are going in this direction, so here it is the opposite of the direction of current, so it will be minus 1 into 2. Now let's simplify. 8 plus 4 minus 2, so it will be 10. What about this? Vg minus Vh equals to 10 minus 3, that is 7. So the voltage drop is 7 volt. So 7 volt battery is connected between these 2 points. Now next question. If P equals to Q equals to R equals to 10 ohm and S equals to 20 ohm, then what resistance should be joined with S to balance the Wheatstone network? So that means this is also again a very easy question. So Wheatstone bridge, you don't need to draw it. It is very easy question, but if you require a clarity, you can draw it. So P, Q, R, S. Now if you see that P, Q, R, all of them are 10 ohm. This one is 20 ohm. So when this bridge will balance, all of them are 10 ohm. That means this will be balanced only if S also becomes 10 ohm. If I can make this new resistance S dash to be 10 ohm, then only the bridge will be balanced. Now how can I convert a 20 ohm into a 10 ohm? To convert a resistance of higher value to lower value, we always have to connect a resistance in parallel. We also always have to connect a resistance in parallel. Now how much resistance we must connect in parallel so that the resistance becomes half? Here 20 was there and our final result has to be 10. So here what happens is that the resistance is dropping to half. That means we have to apply the same 20 ohm resistance in parallel, so that when they are adding parallelly, the resistance is actually half of it. Okay, remember that. If we want to decrease resistance, we must connect in parallel. Now if the decreased resistance is half, then it must be equal. Those two resistances must be equal. For any other resistance, you have to use parallel resistance combination formula and calculate it. Here it is not required, because we know that the final resistance is half of 20 ohm. That means these two must be equal. So we have to join a 20 ohm resistance in parallel with S. 20 ohm resistance in parallel with X. Now next, 4 cells, each of EMF 2 volt and internal resistance of 1 ohm are connected in parallel to a load resistor of 2 ohm. Then the current through the load resistor is. So here we have 4 cells which are connected in parallel. Now when we connect equal EMFs in parallel, okay, you don't need to calculate the equivalent EMF. Okay, when you connect equal EMFs, same cells or identical cells in parallel, the equivalent EMF is actually same as one of them. equivalent EMF is same as one of them. That means if the each of them have 2 volts, that means the equivalent EMF will also be 2 volt. In parallel combination, because voltage remains same, okay, the equivalent EMF will also be 2 volts. What about the resistance? This is 1, this is 1, this is 1, 1. So in case of resistances, you have to calculate the 1 by R equivalent equals to 1 by 1 plus 1 by 1 plus 1 by 1 plus 1 by 1, obviously 4. So R equivalent is actually 1 by 4. Okay, so it is all reciprocal, so don't forget to take the reciprocal. Okay, so it will be 1 by 4 ohm, not 4 ohm. So equivalent resistance is 1 by 4 ohm. Now it is connected across a load of 2 ohm. Okay, it is connected to a load of 2 ohm. Now what? Now you have to find the current. So what is the current here? Very easy question. So total resistance is 2 plus 1 by 4, that is 9 by 4. So current is 2 divided by 9 by 4, that is 8 by 9. Now 8 by 9 means it is slightly less than 1. Slightly less than 1, if you calculate, it will be close to 0.888 ampere. So obviously 0.888 is the correct answer. Now next, what determines the conventional direction of the product of the current and resistance while applying Kirchhoff's laws? So what are the options? Magnitude of the current, values of resistance, direction of current, value of PD. So value is just obviously does not determine the positive or negative value. So as I said, if we are going in the direction of the current, we take this as positive. Okay, if we go in the direction of current, we take positive. If we are going in this direction, current is passing in the opposite direction. Okay, our loop goes in this direction. So this is positive, this is negative, right? So when you go in the opposite direction of the current, that we takes negative. So that means direction of current is important while determining positive or negative value in case of applying Kirchhoff's voltage laws, right? Now next question. The Wheatstone bridge network is shown in the figure. The key K is closed. The galvanometer will deflect in the left, in the right, deflect either side, not show any deflection. So galvanometer is one of the most common concept in COMEDK. As you can see, we are solving so many questions on galvanometer, Wheatstone bridge, and Wheatstone bridge is actually not super difficult for COMEDK. So if you see 20 20 20 20, so it's a double 20 20 match, double header match. So we have a match in the morning, match in the night as well, right? So that means obviously the Wheatstone bridge is balanced, and balanced Wheatstone bridge means it will not show any deflection. Okay, P by Q is equal to R by S condition is satisfied. No need to do any calculation. Simply see the thing, and you will see that because the galvanometer is balanced, no, it will not show any deflection. Next question. A metal wire is subjected to a constant potential difference. When the temperature of the metal wire increases, the drift velocity of the electron in it increases, thermal velocity increases, decreases, thermal velocity increases, increases, thermal velocity decreases, decreases, thermal velocity decreases. So obviously as you increase the temperature, one thing we realize that thermal velocity has to increase. Okay, so if you increase the temperature, the electrons will oscillate faster, so its thermal velocity will increase. Okay, so even though average effect will be not there, but overall for a single electron, if you consider, its thermal velocity will increase. Okay, overall average in the entire conductor, it will not affect the overall conditions, because average of them, average of all the thermal velocities in a conductor is 0. But individually one electron's thermal velocity will definitely increase. Now what about drift velocity? Now we know that I, current in a circuit, is NEA into VD. So drift velocity is proportional to current. Now let us understand what happens when we increase the temperature. When we increase the temperature, the resistance of the conductor increases. When we increase the temperature, resistance increases. That means current in a circuit which is actually given by V by R decreases. Resistance increase in resistance means current decreases. So if current decreases, the drift velocity will also decrease. Right? So drift velocity decreases, thermal velocity increases. Drift velocity decreases, thermal velocity increases. Drift velocity is not constant, by the way, it depends on temperature. Yes, if the temperature is constant, voltage is constant, drift velocity will be constant, but if temperature changes or voltage changes, drift velocity will definitely change. Now, next question, how many electrons per second constitute a current of 1 microampere? So 1 microampere means 1 microcoulomb by 1 second, right? In 1 second, per second means obviously 1 second, right? So basically we need to find how many electrons are there in 1 microcoulomb. Now I always tell my students that remember that 1 coulomb charge is equals to 6.25 into 10 to the power of 18 electrons. Okay, 1 coulomb charge is 6.25 into 10 to the power of 18 electrons. This will save a lot of time. So 1 microcoulomb charge means what? 6.25 into 10 to the power of 18. Now micro means 10 to the power of minus 6. Okay, you have to consider this micro. Micro means 10 to the power of minus 6. So it will be 6.25 into 10 to the power of 12 number of electrons. So correct answer is, now here fortunately only one option has 6.25. If you know this factor even remotely, you should be able to answer it by closing your eyes as well, right? So the question is not super difficult. Next, a wire when connected to a 220 volt main supply has a power dissipation P1. Now the wire is cut into two equal pieces which are connected in parallel to the same supply. The power dissipation in this case is P2. Then what is the ratio of P2 is to P1? So here we have one wire. Okay, so initially suppose the length of the wire is L, resistance is R. Okay, so what is the power dissipation? Power dissipation is given by V square by R. Right, power dissipation in a conductor is given by V square by R. Because voltage is constant, now what we have done, we have cut this wire into two lengths, okay, L by 2 and L by 2. Right, now we connected them in parallel. So we connected them in parallel. Now again we have connected them across the same voltage source. So what is the power dissipation now? Remember that resistance of a wire is directly proportional to length. Here obviously because you are cutting, area, resistivity etc. remains constant. So if you cut the wire by half, then the resistance will also become half. So R by 2 is the resistance. Now when R by 2 and R by 2 are connected in parallel, what is the equivalent resistance? The equivalent resistance will be R by 2 divided by 2. When two equal resistances are connected in parallel, the equivalent resistance is half. Same concept of the Wheatstone bridge problem where we go in the opposite side saying that because the final result is half, we have to apply same value of the resistance. Here also the same concept that when two equal resistances connected in parallel, their equivalent resistance is half. So these are the shortcuts techniques that if you remember will help you to solve any questions in any exam. Okay, you don't need to calculate R1 R by 2 by R by 2 R by 2 into R by 2 divided by R by 2 plus R by 2. You don't need to do that. Okay, if you know this. So that means the resistance is now R by 2. So what is the power P2? Power P2 will be, the voltage is same. Okay, resistance is now R by 4. That is 4 V square by R. Now what is V square by R? V square by R is P1. So it is 4 P1. So they ask you what is the ratio of P2 by P1. So P2 by P1 equals to 4. So the result is 4:1. Okay, or simply 4. So this is the end of today's lecture. All the questions that we have discussed are super important, and as you can see, a lot of questions are coming from Wheatstone bridge. And if you want to practice more such questions to prepare for your COMEDK exam, Then our COMEDK rank booster test series is also available for purchase, and the price of this is only 999. Okay, you can enroll for this today, and again it will start from 6th of April. The price is only just 999. So if you have if you want to practice more questions, more unique questions for COMEDK exam, then definitely you should consider COMEDK test series, rank boosters test series, which will give you 12 full length. Full length means it includes physics, chemistry and math. So each of the 12 paper will have 3 subjects each. Okay, so 3 into 12, which is equivalent to 36 exam paper, right? So 12 full length paper you will get through this test series. So if you have not yet registered for test series, don't forget to register. If you are part of COMEDK crash course, you will get 5 test series, full length test series apart from this 12. So if you want extra practice, definitely you should consider the rank booster test series as well. Okay, so with this note I will say goodbye. I will be back with a new chapter very soon. Till then, bye.